Hi!
Welcome to the channel Behind the Scenes Science, where I will show you actual experiments and techniques on video. Today's topic is about gel electrophoresis. Gel electrophoresis is a technique that separates DNA fragments based on their size. I will show you how to make the gel, run the gel, and view the gel. So all the supplies that I need is right here on this bench. So shall we get started? In order to make the gel, we are going to use the white powdery substance called agarose. And these are coming from seaweed. So we are going to make several different concentrations: 0.5%, 1%, 2%, 3%, 5%, and 10%. So the first thing first, in order to make it percentages, you are going to need a 100 milliliter graduated cylinder. So you just fill it up with the buffer. So we're going to take a weigh boat. Now it's actually 0. I'm going to actually re-zero it myself. I'm going to make 1% of the gel. 1%. Take this. What I like to do is put them in a flask, large flask. So you can see that little powdery white powder. Take 100 milliliter of the buffer. Just slowly pour it in. What I don't do is I don't swirl around, because some of these powder will actually stick to the side of the flask. So let's get boiling. So I have already set up these gel casting for you. So what I like to do is, we have these combs. So if you look at it, one is actually thicker than the other, but I like to use the thicker side because I don't like to poke these gels. So, and the other thing is, I always put the handle away from the edge because it actually gives you that thickness. So let's put all three of them. The next thing is we are going to add lithium bromide. These are actually pretty toxic. These are carcinogens. So I would recommend wearing gloves and handle with care. Mix it just carefully and then pour slowly. You don't want to have any air bubbles because it's going to mess up your reading. Let's make another one. So here I am back at it. I've already made all these gels, and it's a pain to make each gel. Now what I will do is I'm going to actually pull out this little cones from the gel carefully. I use this glass to actually cut these gels. Start with this little cousin, 0.5%. So I'm going to need 2 wells. So well 1, well 2. So I don't need well 3. So I'm going to cut a little bit close and slice it down. That's easy. Rest of them could actually go back for future use, but this is what I will be using. Have you ever cut like hard steak? And this is what it actually feels like. Hard steak that you actually need to put some force. Oh, great. There you go. So now I have 0.5%, 1%, 2%, 3%, 5%, and 10%. Let's load up the buffer until the fill line. There we go. As you can see, this is really clear. So what I like to do is I like to put some color underneath to see where you actually put your samples in. I will be right back and get that sample. First thing first, I am actually going to load the standard or the DNA step ladder. This is 0.5.
Alright, let's see what happens.
So I have this DNA samples that I'm actually going to load on the other well. DNA that I want to figure out if they are correct or not. So let's start loading them and see what happens. Next step is how do you determine the speed to run the gel. I have this ruler and I'm not going to slap somebody with it. And I have this gel machine that's about 16 centimeter and I want to run around 7 volt per centimeter, which is around the speed that to actually get a decent result. Put the lid on and turn off the power and let's get it started. So I put a negative to positive because the DNA will travel from the negative to the positive because there's a lot of phosphorus in the DNA. That's fun. So let's stop right now. See that gel actually has started all equally at this same line and now it's actually traveled this far. Alright, so we are now ready to view these gels under the UV. So this is a UV box where I put all the... Ooh! I broke. Hopefully it's there. If not, I'm sorry. So this is what it looks like after taking a picture under the UV. The DNA fragments in 0.5% gel had traveled the quickest compared to the 10% gel, and the small DNA fragments can be seen clearly in same amount of time when running under high concentration of the gel. Here is the visualization of 1 kilobase step ladder so you have an idea how much DNA had traveled through the gel. It's like filtering through a mesh to separate things based on size. Now 10% is just too difficult to deal with, so don't bother making it because I have done it for you. So I hope the overall visualization gives you an idea of what percentages to run the gel based on the need for your experiment. That is how you run gel electrophoresis. You print them out and you save this somewhere in your lab notebook. Before you close out this video, this is what 10% looks like. It doesn't break. This is 1%. I can't even slap it. This concludes this video. If you have enjoyed this content, consider hitting the like button, the red box, and the bell button. I'll see you on the next one.